Well, research is all about the unexpected. I mean, if I knew what I was going to find, I would have probably, it wouldn't really be research because I already know the answer. So research is really kind of an exploration into the unknown. And the unknown, by definition, gives you unexpected things. That's what makes it fun.
From my experience, the unexpected is the norm, in the sense that most interesting research is interesting because it leads to unexpected results. If we always confirm what we expect and we don't find any surprises, then it will not be interesting. The reason it is so interesting is that we are constantly surprised.
And most of us have got these wonderful moments when either you predict something, you carry out an observation or do an experiment, and you find what you were looking for, something which was happening. And these are always very exciting. But in addition, there are those where you do the experiment, you make the observation, and something totally unexpected happens, which opens up new frontiers, new ways of looking at problems.
The unexpected in science happens every day. It's bringing the part of the challenge and part of the reason why we do science is to make new discoveries and to find those serendipitous results that give you new discoveries and new insights into a biological system or a biological event. And that's kind of the key to why we do science and what we do on a daily basis.
In many cases, what I found is that I had a given research goal in mind, but then research itself has led me in different directions, and what I have ended up finding was much more interesting than my original preconceptions. So in this respect, the unexpected is not something that is a problem for the research. On the contrary, it's at the deepest nature of scientific research.
Actually, it's the unexpected which makes the best discoveries, because if you expect the discovery, if you go after it, if you already have the hypothesis, it is much less of a novelty anymore because you're already predicting it to happen.
It got me excited because I realized that while science is hard work, and often we have to methodically plan what we're going to be doing and how we're going to address specific questions, there are times when we find things that we did not expect. Because the universe is full of surprises, it's full of activity, and I find this to be a really fun part of science, that you never know what's right around the corner that's going to surprise you. And then that gives you another thing you can study. So I went ahead and studied that comet for a long time with telescopes. I observed it over and over again to try to see what it was made of, what it was composed of.
And this particular PhD student happened to leave these Petri dishes in the incubator over the weekend and forgot about them rather than throwing them away as we would normally do. And what we found is when we came back, that these bacteria were suddenly able to move, and this was really unexpected, and we didn't know how they were doing it. So this led to a whole new research project.
The most unexpected result in the history of biology would be the discovery of antibiotics a long time ago. This was a pure accident because someone was growing some bacteria on a plate, and when they came back from a long weekend, they found they had disappeared, and no one knew why. And they discovered eventually that there is an enzyme or chemical which can destroy bacteria, and this was the first remarkable discovery of antibiotics. I think that was completely unexpected and an amazing discovery which has transformed the life of so many people, because antibiotics are used for almost everything now.
The Higgs discovery is an odd one because in a way it was completely expected, although we didn't know the mass of the Higgs. I think many people would have been more surprised if there was no Higgs boson there than if there was one. Thinking back to the time when we were looking at the histograms and seeing whether there was really a Higgs, we looked for a bump in the plot to see whether there's a Higgs, and the plot's jiggling around because of statistical noise all the time, and you're always watching to see if one of these bumps is the real bump and it's going to stick around. And I remember on the 3rd of July when we'd actually, on Atlas, on my experiment, we'd seen our data and we had a significant bump there. And we kind of knew then that we'd discovered something. I did have this kind of gut feeling of it being unexpected, that the maths behind this really actually did have anything to do with the real world, and this bump was the evidence that it did. So that was one sort of unexpected, but a very long-term contemplative kind of unexpectedness.
I think also the parallel postulate from Euclidean geometry. The fact that for years people tried to prove this on the basis of the other, of Euclid's axioms for Euclidean geometry, and of course they could never prove it because it's not true. There's a Lobachevskian geometry in which all the other axioms hold, but the parallel postulate does not hold. And so that was certainly unexpected because people tried for several hundred years to prove it.
So it removes the gene you want to remove, but it doesn't remove any others. That's how it looks at the moment. And that's immensely valuable. And you can use it the other way around to introduce new genes and where you want in the genome. That's remarkable. So if you can again take a patient who lacks a good gene, you supply the good gene and can put it into the right place, that would be of enormous importance in alleviating human disorders. So it's very recent work, but it's looking very good, and I expect they'll probably give someone a Nobel Prize for that if it works well.
Also, in my own past, I've also had the pleasure of making an unexpected discovery, and that happened many years ago, almost 30 years ago now, when we did the first large-scale sequencing. We sequenced the largest human virus, that's one, the human cytomegalovirus. And when that was sequenced, the analysis revealed one gene that stuck out, which shouldn't have been there. And it could easily have been a contamination. It was a human gene that was found stuck in the middle of this virus, and it couldn't be explained how it got there.
It seemed to me that there are perhaps two sort of unexpectednesses in mathematics. I mean, the first is unexpected facts. Something just turns out not to be the way that one thinks it's going to be. The other is unexpected connections. You know, that people are working in a certain area, and suddenly it turns out that ideas from a totally different area of mathematics are important and relevant. And so that's some unexpected connections, I think.
During my research as a mathematician, I've definitely encountered unexpected things. I think probably the most frequent of these is if I'm working on something and I come up with some strategy to prove a theorem or something like that, and you do the due diligence and you ask around to see if someone else has done this piece of mathematics, and occasionally you find out that someone has done it, but in somehow a completely different context or for a different reason or a different even subfield of mathematics. And so the unexpectedness of this is the connection, actually, that something I'm working on that I thought really just applied to this one situation actually has connections to other parts of mathematics.
I think also the unexpected is about creativity. So I was saying almost all my best ideas come from connecting two things that I didn't think were connected originally. And it's not actually such a linear process. It's not like I sit and observe something and then wonder, how does that work? It's more that I'm thinking about things and suddenly I'm sitting on a bus and I think, what if I do this and this? And then I go try it and something completely unexpected happens. It's very more like creating a piece of art or a piece of music than it is about just sitting down rationally. Once you've come up with this thing that you think is unexpected, then you need to use the scientific logical methods to see whether you're right or wrong. But the unexpected enters in a very unexpected way.
When I was a beginning graduate student in the Cavendish laboratory, and Martin Ryle asked me to try to find the optical objects associated with the radio sources which had been discovered. We had the best positions then. And I wanted to do theoretical cosmology, not ruin my eyes by looking at plates and trying to find these things. But I did the job. And in that process, I discovered an object called 3C9, which turned out to be the most distant quasar that existed at that time and remained the largest redshift quasars for about 8 or 10 years.
As opposed to the textbook picture of scientific research, when there is goals, there is some methods, and there is results. It's much more dynamical process. We have some ideas, we start to investigate, and we end up finding things which most likely were unrelated to our original goals, but on practice, they are much more interesting than our first ideas.
That was extremely surprising and very pleasing, especially for me because I did not contribute to the math. I know very little about the math, but it's extremely satisfying when one does something to solve one problem. And as a byproduct, it solves some other problem that was not even intended to solve. So when we discuss surprises, I think this one qualified as a big surprise. What I think needs to be done is to pay attention to these surprises, because the gut reaction is to dismiss them, because we have our prejudice, and when the facts are inconsistent with our prejudice, we typically feel like, well, our prejudice is right, there must be something wrong with the facts. But that's too fast, and I think one should really pay attention to what one discovers, and if there's a surprise, try to capitalize on it, try to use it, and realize that if we had a mistake in our maybe we had a mistake in our prejudice, and that would lead us to deeper insights after we fix the mistakes in our prejudice.
Even Turing, who codified the notion of algorithm, the notion of decidability, he actually expressed the belief that this might be an unsolvable problem. But shortly after he said that, just a few years later, Wolfgang Haacke proved that actually it was solvable. And again, you asked about the reaction of mathematicians to that. I think that with that particular example, there was the reaction was one of skepticism. It went against the prevailing wisdom, and so people thought, well, the proof's probably not right. But of course, it turned out it was correct. And
for science, you just need a lot of patience and be very observant, because we are investigating unexpected. So very often things don't work. So it can be quite frustrating for a young PhD student, because they come with a lot of enthusiasm, and then most of the things don't work because you investigated the unknown. So most of the time your hypotheses are incorrect. So that's why it takes a lot of patience and optimism and hard work. Yeah.
So I think this is probably very common in mathematics, in the sense that one's first instinct as a mathematician is to think that the situation is the simplest one that's consistent with your observations up to that point, you know. And so you conjecture, or you think that a certain statement is true, and then frequently it turns out this to be more complicated than you thought, and you have to take into account other examples perhaps, and then you have to modify your first guess. And so I think in this sense, doing mathematics is frequently, there's a lot of little unexpected things, perhaps not big unexpected, but a lot of little unexpected things crop up as you go along trying to understand what's true.
It's hard to get unexpected science funded. You have to have a very clear idea of what you want to do and exactly what the results are going to be. But the beauty of unexpected science is that it can go in any direction, and it can reveal things that you've never thought about. So my research focus has completely changed direction since this research project.
That's a great thing about being a researcher. You're exploring this unexpected, surprising landscape. And most new discoveries are really about things that you didn't think were going to happen. And they're different, which is what makes them fun. What makes you good at research is recognizing that something unexpected has happened. Very often things happen and it's actually unexpected, but nobody sees it. Or it just misses you. So you've got to be able to observe and think about it and notice, hey, that's strange. So whenever a student and I are talking about a research project and one of us goes, that's strange, why is that? Then this is a clue that something exciting and unexpected might be happening.
Preparedness of mind is extremely important, because so often one does obtain unexpected results in the laboratory, and sometimes one just says that means nothing. But if your mind is prepared, ready for unexpected events, it really helps a lot. And then you say, that might be really interesting, so I think I will pursue that. The person who has a prepared mind is able to do that if they were not prepared, they might miss the opportunity.
Researchers should really keep an open eye because the surprises are just lying around us, and we should just jump on them when we see them.
Then it's always a pleasure because it gives you some new perspective that you didn't understand before, or maybe it gives you some new connection to someone else's work, and so it's almost always a positive thing.
There are two main reactions in front of the unexpected. The first one is of surprise, and the second is of gratitude. Surprise because while we have some ideas of what we can find during our research, in many cases what we find is much more interesting than our original preconceptions. And this leads to a feeling of research which is always extremely captivating. But the second, which is perhaps even more interesting, is of gratitude. Many people, when faced to a new discovery, are extremely grateful of the possibility that nature is comprehensible. This might seem obvious, but it's far from it. How come our universe is comprehensible? How come we can describe it mathematically to such astonishing degree of precision?
I was in London then. I'd gone back from CERN to London, and I knew the ATLAS data, but I didn't know the data from the other experiment, CMS. And Jim Verdi and I showed each other the data before the big announcement from each other's experiment, because we'd heard rumors, but we didn't know exactly what each other had. And what was unexpected then was when I saw that CMS had exactly the same thing as ATLAS, I reached another level of certainty about the Higgs. And if you'd have asked me 2 seconds before, I'd have said, no, we've definitely found something. But it turns out I didn't really believe it until I saw that another experiment had the same thing. And that was a bit unexpected because we really thought we knew. I mean, I thought I was certain, but it turns out that you're never certain in science. There's always more evidence can take you further.
In this case, my student had an idea that seemed strange to me at first, but ended up explaining a lot of what we see. And I never would have guessed that it was that way in advance. Although now that I've understood it, I can look back and it all makes sense. But in advance, it's surprising.
But then when I ran my analyses, I actually found that emotional abuse had a much stronger effect on the way that people think about themselves. And actually, when you think about it now, it makes sense that when you are often told that you are worthless and that mummy doesn't love you, then you incorporate those cognitions into your self-image.
I've been close to many wonderful discoveries. I was in the office next door to Tony Hughes when the pulsars were discovered. I was a third-year graduate student when the microwave background radiation was discovered. And of course, just within the last year and a half, we've had the discovery of gravitational waves, which is completely mind-blowing and changes your whole vision of how high-energy astrophysics should be carried out in the future.
That moment of seeing this total chaos suddenly resolve itself and knowing that you'd come up with a hypothesis and implemented it and suddenly everything fell into place was really exciting. I mean, it was very, it's technical. It didn't change physics forever, although it did make our experiment work, which was important. But it was a really nice example of how all the stimulation and preparation in the world, it did help, because if we hadn't done all that work, we wouldn't have solved the problem. On the other hand, it doesn't eliminate the problems. You have to still keep your wits about you when you're confronted with nature and real life.
I think the unexpected in scientific discovery is telling all of us, whether we're scientists or not, to keep your eyes open, keep looking around, look in the periphery of your world, because there may be things happening that are very important. They may be subtle. You might not have noticed them at first, but those things may actually be very important to the big picture of what's going on.